Begin, we are going to make the shooting turned off when we are clipped. So just simple changes here. As you can see, it's clipped is also or, and then just gonna make this short form. Just gonna add the comment. Also we have then delete this, save, and we can try it out. You'll see that if I go and get my gun clipped, so here is position, and now if I click, I cannot shoot. If I do come out of that, then I can shoot. So you can see I can, right? So that doesn't work. So now you're gonna reload automatically if we don't have any ammo and the player is trying to shoot. So let's add a function, try reload, comment out the actual code for that, and we're gonna call try reload when we get the input. Whenever we get the input, we're just gonna try reload. And also, let me get that code exactly, paste it in here, the shooting one, and make that an else if, and the gunshot timer is less than or equal to 0, and we don't have any ammo, so the current weapon's ammo, you can say is reloading is false and is slipped is false, right? Well, actually that's gonna already be in there in the try reload function. So current weapon dot current ammo is equal to 0. Okay, we try reload in that case as well. Now we have to fill out this function. Just gonna paste that commented code and uncomment it, remove that, and that will fix our problem. So as you can see, we also have this which checks for us we have lesser than that, so if we do, otherwise we won't. So yeah, it's also checking for the gunshot timer, which is pretty good. And then we start the reloading time 14. That's going to actually get that to reload, I think, when we have no more ammo left. So this is going to be a bit of a waste of time, I think, as I'm trying to do it. So I can reload by default, and if I shoot continuously, what's going to happen is if I shoot again, shoot one more time, and now if I click, you can see it just auto reloaded for me. So I think it's working. Yeah, so if I can just shoot again, and try to shoot now, it's gonna just go into reloading. Well, that's, I think, exactly what we're looking for. And if we try other weapons, so let me just get one from here. Got this fast weapon, and if I fire continuously, you can see that it automatically started reloading, which is cool. You may notice my weapon going really fast. Now we can remove that commented out stuff and add some comments for the code. It's just gonna add a summary to this function, and yeah, call this function and try reload, and we can save that, and that's it for this part. Okay, so we're gonna improve our decal system. Start, we delete the decals folder of the scripts. I'm gonna create a new script and call this the bullet decal object, and I'm gonna open it up and add a comments decal prefab. I'm gonna do a space header bullet effect prefab, and then we'll just add a serialized field decal prefab. We are going to inherit from mono behavior and also an interface iHitable. We have this nice function that we can use, public void with hit. We've got the game object, hit object, the hit point, and the hit normal. We can go in now to game object decal is equal to instantiate decal prefab at the hit point and the look rotation of the hit normal. We will render the rotation for more realism. Decal transform, or rather transform to rotate from around the forward axis of the effect from 0 to 360. We're going to child the effect to hit object. For that we can actually say the quite simple code, so it moves with the hit object. Decal.transform.setParent, and we'll simply say hit object.transform. Once we save that, it should all work. Create a new folder. This name of this folder can be bullet decal effect drag the script in there. Next, we can select these three, or just open up everything and select all of these. Well, these have different ones. I'm going to select the same one so I can remove it. Then select these together, remove that, and forget that. Right now, I need to add this component to the decal object and give it the stone impact effect. So I'll do that in a speedy manner. So first delete that, remove it, add my component. And now I do it really fast, so I'm just gonna go a bit extra speed. And we have got the simple objects done. Now we have really nothing left. The gates, I like to remove. And now if we hit play, you'll see I can shoot and shoot again. Why am I shooting? Trying to get out of the aiming. Try to shoot there. You can see the effect is indeed working. Let me shoot this. So if I shoot, there it is, and the effect did appear. Now I'm going to be adding basically some random rotations. So how we do that is, first I'm going to make it look rotation in the direction. The target direction is a new variable I just renamed from the direction. I'll create a new function that returns the vector 3. It's called randomized direction, and we're going to take in a vector 3 direction. We're going to take in a float max angle. We're going to define a local variable, float angle. It's going to be a random dot range from Unity engine, not system, between max angle minus and max angle. We'll calculate the rotation. Quaternion rotation equals to angle axis, passing the angle, and we're going to get vector 3 dot up. Next, we will also get this to randomize on the other axis. So this is random rotation y and rotation x. We get from the right as well. So for that, we will also go and define quaternion rotation y multiplied by rotation x, and we're gonna get the rotation times direction. Return that. Here we can define vector 3 direction is equal to randomized direction. And yep, if we save, we can come back here and hit the play button again. Now we will see that the direction is indeed being spread out. So if I shoot, it is shot a bit differently. Actually, yeah, farther away you will see that yes, it's not 100% at the point. Well, actually another weapon will actually prove to you. When I get another one, let me just try to get it. Yep, got it. Now if I come over here and I fire this bullet, you'll see that it's not shooting in one point, it's shooting at multiple points, which is what we're looking for. Now I'm going to pass in weapon data dot max bullet spread angle, and we're going to define that in the weapon SO. We'll go down here and basically come down to the max shoot range, or rather keep back up there. It's a hardened inspector public variable. It's a float. It's max bullet spread angle equal to 5 by default. Next, we're just gonna go to the actual edited script, define a serialized property with the same name. Then we're just gonna find that, searching it by using find property. Next, we'll just draw it. So we're gonna find that place where we have the reloading animation time, and below it we draw this field. So we're just gonna update this script, as I found kind of a bug or something. We're gonna define a serialized field private transform decal effect child or parent, where all the decal effects are child or pooled. We're gonna create an audio clip, the hit object clip. Tooltip optional. This will only play when the hit occurs. So anyway, tooltip up there. Assign a parent whose world transform is uniform. Basically, it is 111 in the real world. So that will make our decals appear nicely, not scaled oddly. Alright, then in the tooltip for the hit object clip, we'll say assign only if you want to play an audio effect when a hit occurs on this object. Now to get this to work, inside this place we check if the decal effect parent is not equal to null, then we want to set the parent to the decal effect parent. Otherwise we'll just do the same thing. So that's one thing. Next, down here I'm going to check if the hit object clip is not equal to null. If it is not equal to null, then only we'll play the clip at point. The point hit object clip, sorry, the clip is that, the position is hit point. The volume, well, I'm just going to make a nice slider for the people to select the volume as well. Audio volume equal to that, and we're going to add a range to make it a nice slider. Save, and yes, then we're going to pass in the audio volume. Save, and then it should actually work. So as you will see, we'll create a parent uniform and drag it in the slab because this one has a non-uniform transform scale. We'll pass in the decal effect parent. As you'll see now, I'm going to shoot and everything seems okay. Random rotation is also happening to give us a realistic perspective of the decals. If I change my weapon, now you can see it looks much nicer. Alright, so we're just gonna close everything, and I'm just gonna add a new serialized field, private vector 3, decal effect scale, vector 3.1, just in case you want to actually scale the decal effect. So what we're gonna do is change the local scale to the decal effect scale. And just add some nice comments to make it nice and readable. Save, and we should be back here. Also want to add a tooltip to the audio volume. There you are. So just letting you know this is useless if you don't add any hit object effect volume. So if we change the effect size 2.4, you'll see that in real time it's actually going to be changing the scales. So if I fire, you'll see that I've got a smaller effect than the actual original, which might be what you're wanting. And this is actually the uniform one, which has a different scale. Anyway, so we can set that to 1, as I don't want to make that 0.4. And I'll assign a clip so that you can hear that. But actually, it's not actually so reasonably hearable, so I'm just gonna change the audio clip so I can hear it really. Well, I'm gonna put a very obvious one, like maybe why are we getting an error? Well, yeah, like passing in one of these gunshots, so we'll be able to hear that. Or the reloading will be very obvious. Now if I shoot at this thing, I can hear a reloading audio clip play, so yep, it works. But I don't need to assign anything now, just remove it, and that's done for that. And the randomized direction function, I'm just gonna add a simple summary to it. Takes in max angle. Alright, cool. Basically what I mean by bump rotation on a shot is it's gonna literally just change the X rotation by minus equal to some value, which is going to be from the .weapon data, the current weapon, bump rotation amount. So our spine is going to rotate upwards, something like Ghost Recon, which it does when you shoot. So I'm just going to do that as well. So here you go, I'm defining a simple variable with 2 as the default. And then in the serialized property, I'm going to just define that, get it as well, find it, and just give it. Then I'm just going to draw it using the draw property field, and now we'll just use it here as the dot shot bump. And if I save, come back here, you'll see it works. Now if I change my weapon so I can see it more reasonably, I have to try and get this thing. So now it's working, and you can see that when I shoot, the camera actually rotates upwards. You can see the whole rotation is being affected. And we can change this through these values from the scriptable objects. Yes, we made it super slow. We can make it really a lot. And then shooting ones, you can see it's just taking us really fast. And it's overrideable by your mouse, so you can force it downwards. So it is working. So you can see I can like override it. And the spread, we can change the angle. So now what I'm going to do is define a camera target position. I'm going to basically be rewriting this function, the camera function. I'm going to have a smooth cam speed. I'm going to delete this function and rewrite it. So if it's clipped, set camera holder position and rotation. Camera target position is equal to camera holder, and then for the rotation. And if we are not aiming, else if not aiming, or rather else if is aiming, it's gonna paste the same code, whereas it's gonna be using the camera holder aiming, and we're also gonna be using not aiming for the normal, that would mean normal position. We'll set the camera holder dot position using lerp to the target position using the speed that we've got, and the rotation in a similar way. And just add a bit of comments. We'll also position the camera targets actually, which is quite simple. We'll set the local position to that, and that. Not aiming to normal, and aiming to aiming, and clip to clipped. So as I hit the play button, you'll see it all works. The camera is actually working just like it should, and we can actually get this one as well. Right. So I'm gonna start adding leaning and peaking. We're gonna add a simple input action for this. In our input actions, we're gonna have a lean input action with axis, and we're gonna add quick Q and E to the keyboard. Save the asset and move to the script. I'm gonna move the current weapon settings or setups into the awake, because we need that to actually, basically it's better to do so. Then I'm going to define a new region for this, leaning and peaking. Simple space to start, a header, leaning, peaking. We're also going to have serialized field, primary float, leaning input, smoothing speed, which is 10, float leaning angle, which is 30, and a private float leaning input. So the leaning is going to be done in this function. Look, I'm going to change this to float, from float to vector 3s. I'm going to remove this, and instead of floats, we'll take in vector 3s and rename them to clip projector and center spine targets. Then we're going to actually pass in a vector 3 with spine tar.z, which we'll define in just a bit. So I'm going to define a leaning section here. Leaning input equals to input.player.lean, not read value, and there's going to be lerps, so we use the speed. So set input and smooth, float leaning amount, which is going to be calculated using the leaning input multiplied by the leaning angle. Alright, then we have a vector 3 spine tar, which is just a spine target. We set this to the new vector 3 x rotation, comma 0f, comma minus leaning amount, and we'll make use of this variable. So as you can see, that's how I've used it. In the last one, we just use spine to spine everywhere. So all that does work. And in this camera, I'm just going to change something. So everything's going to be local, local, local. And I'm going to add Z off to camera target rotation. So camera target rotation dot set or nothing really, just set it. So it's going to be multiplied by quaternion Euler minus center spine pulse dot local dot Euler Z. And everything back to local, as you can see here as well. If I save that, for the rotation, I'm just going to actually add a copy of this on top of it. This is going to be quaternion.yoda, and we're going to set the camera holder to do the camera holder rotation, which is a vector 3 camera holder rotation, new vector 3. You'll pass in the camera holder dot local rotation.yoda.x, camera holder dot local rotation.yoda.y, and in this case we'll pass in minus center spine dot local rotation.z. Get camera holder rotation plus z minus off, and we'll pass in camera holder rotation as there. Save, and everything should be smooth and nice again. So if I hit save and I hit play, and first of all we need to fix this error. So this is basically saying that, yeah, so I need to get this inside of it as well, the weapon, otherwise it's null, so it can't set it. In the player UI, I'm just gonna make a small change. So I'm going to define a weapon base. This is actually some nice, I'm just making this look better. So weapon base current weapon, instead of getting it again and again. Save, and I can simply go here. And now you'll see it works. So I've got a simple error that's really just maybe a bug or whatever. Nothing wrong with our system. So as you can see, I can lean. We can also change the leaning angle, so like 50. We can make the input smoothing speed as well. That will just change the speed of the leaning or whatever. So I'm going to set the leaning angle to 20. And that seems quite okay with 10 on the leaning input. So 25 and so we're just going to hide and lock the cursor, as that's something that we should do. It helps when we are also working, and of course in games it should be. So we lock the cursor by simply in the start function cursor.lockState equals to cursor lock mode.locked and cursor.visible to false. First we do that and then we lock it, which is going to do exactly what we want. So we can save, and there you are, hit play. So if I click once, you can see my mouse is no longer visible, but I can still rotate and move around, and if I press escape I can get out of the lock state and everything and re-enter it as well. That's cool. Now we come to the next thing, which is to create a simple folder inside the material section, inside the player rather. Just create a material and call it clip proj visual material. This is going to be a transparent material to help us visualize the clip projector. I'm going to set it transparent as a surface type, receive shadows to false, and the opacity to 100. And the color is just white. So if you save, you can see this now. So I've actually changed the size of this weapon, the actual clip projection, as you can see. Maybe make it unclippable, clickable, then we won't be able to click on it. But I think we'll leave that for now, like that. So I changed the size from here of the AWM weapon, as you can see. So that's just so that I can peek with ease actually. So I'm like this, and I can have a peek. So if I pause and I look, you can see that we have that silver thing showing up, and we can peek as well. So you can see I can peek at the right point, then I can actually peek. So it's peaked right now, and if I aim also it works. I can shoot at the same time as well, and I can aim. Reloading is also possible. Now I'm just going to fix the problem, so I'm going to add an interact pointer game object inside clip projector pos. Then in the handle interactions, instead of player camera, we'll use a variable that I'm just going to define. There's going to be a transform. Its name is going to be interact pointer. Just a bit of space. And instead of player camera, we'll use interact pointer. Save that, and we can come back in here. Alright, now it will work. So here I am, and if I set my cursor on this, why is it not coming? Well, actually the pointer is messed up. So let me just reset the rotation, orientation, everything, and then reposition it as well at the correct position point, somewhat there. I think you would say should be a fixed point, right? So now, even if I'm clipped, I can actually see that bar appearing, and we can actually interact with it. So if I click the button, yes, you can see we just interacted it. Alright, cool. Now that's working. You can see that this weapon's actually, the thing is actually a bit messed up. If I add a full transform to the interact point and set to camera holder, it's gonna follow the position only, which is not bad for us. It's good, and it will work, you can see, because it's not following the rotation, only the position. So I think it's good to just add that component with the camera holder assigned. So save the project, and that's it for this part of the video. Next part. So we're going to remove the gun holder from the bone hierarchy of our character because it's a more quality approach. Disable the weapon. We're going to copy this and paste this in here. So we've got a gun holder copy right here. I'm going to set the rotation to 0. Copy the world transform, that one, and paste in here. And set rotation to 0. If I copy the spine position and just paste it here, then I should actually go and copy the gun holder again. And copy the world transform to give the center spine the exact point we need to get to be. And it should work. So that's at 0. Save. It does. Now in the weapon, I'm just going to enable this one and disable this one's weapon based script. I'm going to assign the correct pistol holder, gun holder as well. Next, I'm going to go to this place, and instead of this, I'm going to actually set it to 0. Before it was actually that value that was just written. I had comment out, but that was originally, so we just made it 0. Now if I hit play, it seems a bit odd, so we'll fix that. Basically select the actual gun holder, copy its transform, create a game object, paste its world transform to it, and copy the local position of that object, and then paste it down, as you can see. And now it's gonna all work. You can see that it did actually. However, we have lost our head bob, which we will have to do in the basically with the soy. I've got the soy actually changed. You can see it's different slightly. So when I'm actually going in movements, you can see that the head bob isn't really working, but clipping and everything else is indeed working. Peaking and everything is still working, and that's pretty good for us. But the head bob isn't really working because the head bob is actually the parent in this case. So we're gonna actually have to animate it using another object, which is going to be a child of the bone hierarchy, and it's going to be following it, the gun holder. But we'll see how we're going to animate it in the maybe in later videos. But right now I'm going to create an empty game object in just a short while. Disable the head bob script. You'll see that everything is working, even the bump effect is working, everything seems okay. Just this head bob script is useless, so we're going to delete that. I mean, disable it for now. Delete the gun holder's child and make it a gun holder animated. Basically this is going to be the animated version of the gun holder. It's going to be used for running animations and every other animation that we apply to the gun from our motion animations. So you'll see that nothing's going wrong right now, and everything's working normal without any head bob but in any state. Alright, I'm going to remove that component, and I'm going to go to the gun holder animated, and I'm going to create a new empty object inside center spine boss. Basically right click, create, and this object is going to be the parent of the gun holder. Make sure to keep it 000, and then I'm going to add the script for transform pause and rod and give in the gun holder animated. Okay, let's save that. If I hit play, we have a problem. Well, that's because the offset is not correctly set up. We just need to set an offset for -50. And you'll see I can actually add an animation to this in the idle. So if I go and add this game object, you can hold animated, that's part of the bone hierarchy. And if I animate this anywhere, as you can see, so if I select this and I just make some basic motions, so you can see like there's an up down motion and it's going to go like that. So that's cool, but I'm just going to delete that because we don't need it, right? So I just removed it, and you can see it's not keyframe anywhere now. I deleted it from underneath. And yep, I'm going to rename this game object to gun holder animated follow. And we get an error. So what I'll do is basically come up here and basically I'm going to define a fold transform pos and rut private. This is going to be useful because of the fact that where did I just put it? Down here, right? Paste it here underneath gun holder. So this is you're going to actually override the offsets because we don't want to do this manually. Every weapon has a different one, the Y or spine offsets. I'm going to make the position and rotation offset of this script public so I can get an access to it. So I can say the rotation offset is equal to not quit neon or the new vector 3. I'm going to pass in 0. Current weapon data spine constraint offset y minus. It's a minus at the start and then 0. So that's it. And save. We can come back here. I can assign this. If I hit play again, and now the offset was automatically assigned, and if I change my weapon it will automatically change as well. So yeah, let me just go and get one. Everything seems to be working as expected. The offset cannot be changed, I think. Shouldn't be. Should not be changeable, as my script is overriding it. And I actually changed the, if I change the spine constraint Y offset, if I do, then you can see it's all working because the offset has been modified. And thanks for watching. See you in the next video, and make sure to subscribe and like.